Okay, in this next question, we're solving another form of inequality, but this is going to be a polynomial inequality. I'm not going to graph this one. If you want to graph it on your own, I recommend using the multiplicity theory, and also the leading term analysis if you want to graph him on your own. But for right now, I know that on a final exam, I'm going to be timed and I need to be expeditious, so I'm going to look at my sign analysis. So my sign analysis of polynomials is slightly different than my rational functions because I won't have any vertical asymptotes with rational functions. I'm sorry, with polynomials. I only have vertical asymptotes with rational functions. So here, my critical points will only be my zeros. So in the last example, we had zeros and vertical asymptotes, but clearly here we don't have any vertical asymptotes. So I'm going to solve, and I get x minus 2 equal to 0, x plus 6 quantity squared equal to 0, and x minus 2 quantity cubed equal to 0. These are all the possibilities where my graph can change signs. Solving here, I get x is equal to 2. Here, I get x equals to negative 6. And here x is equal to, be careful again, another value of 2. So notice this was sort of a little, I didn't recognize that's a little, we have to be careful about this because in reality what I really have is x plus 6 squared times x minus 2 to the fourth is less than 0. Because I can combine x minus 2 to the first times x minus 2 cubed, and we get x minus 2 to the fourth. So be careful about this. Now we're going to send up our factors. We're going to set up our factors. So I'm going to do it two different ways for our sign analysis. I'm going to assume that we missed the fact that these are the exact same 0. So I'm going to set up x minus 2, then I'm going to have x plus 6 squared, and then I'm going to say, x minus 2 cubed. I should recognize, okay, I got an issue. I got to combine these because I have 2 that occur twice. But let me go ahead and list the negative 6 first, and then the 2. So if I look at this, x minus 2, I'm doing this a little bit faster, x minus 2 to the right of 2 will be positive, to the left will be always negative. X plus 6 quantity to the second power, anything squared will always be positive no matter where we are on the number line. X minus 2 cubed to the right will be positive. To the left, if you plug in a value like 0, 0 is an easy one. 0 minus 2 is negative. Cubing it will still be negative. So we get such. So f of x will be a multiple. Negative, positive gives you a positive. Negative, positive gives you a positive again. Positive, positive gives you also a positive. So let's go ahead and see what happens with my sign analysis. If I would have caught these two are the exact same 0, I would have still got the 0 of x equals to negative 6 and x equals to positive 2. Setting up the exact same way, I would have negative 6 and positive 2. And here I would have x plus 6 squared and then x minus 2 to the fourth. I hope we all recognize if I raise any value to an even exponent, whether it be 2, 4, 6, or 8, we know we are always positive straight across the board. It can never, ever, ever be negative. So here's positive, positive, and positive. So notice we want to find out where this guy is less than 0. Not less than or equal to, but less than 0. Where is he negative? He's positive, positive, and positive. He is negative nowhere. So therefore, this answer is no solution. He's never negative, no solution. So in this circumstance, he is never negative. He is always positive. Therefore, we do not have a solution that can solve this. There is never a value you can plug in that will ever cause this to be negative. So again, sometimes these seem a little bit tougher, but using a sign analysis can be very helpful. If you were to graph this guy at negative 2 and 6, we have some zeros, so negative 6 and then a value of 2. He's going to come in here, bounce off, come back down, bounce off, and then continue on to positive infinity. He's never below the x-axis. He's always above the x-axis. So in this circumstance, he's always positive. So in number 39, this one is jumping back a little bit earlier, but again, practicing our rapid equation writing of linear lines. So this question says we have to write an equation line described in the following. Express our answer in slope-intercept form. So in part A, we have an equation through negative 2, 1, and is perpendicular to negative 3x plus 2y is equal to a value of 1. In order for us to find the slope of this line, we're going to convert it to slope-intercept form, which is y equals mx plus b. So we're going to add 3x on both sides. So we get 2y is equal to 3x plus 1. Divide both sides by 2, and I get y is equal to 3 halves x plus 1. So our slope here is 3 halves. Therefore, we know the slope, I'm going to write it over here, the slope of my perpendicular line will be the opposite reciprocal, which will be negative 2 all over 3. So now we can use our rapid method for writing an equation of a line. Take the numerator, place it in front of the x, change our sign so a negative becomes a positive, take our denominator of the slope and write in front of the y, and now just plug in. So we're going to have 2 times x, but x is negative 2, plus 3 times y, but y is positive 1. So 2x plus 3y is equal to negative 4 plus 3. Continuing on, we will have 2x plus 3y is equal to a value of negative 1. Solving, we're going to subtract 2x on both sides. So this gives us 3y is equal to negative 2x minus 1, dividing everything by 3. So we get y is equal to negative 2/3 x minus 1/3. So that would be your answer to A. So part B says we want to write an equation of a line that passes through negative 1 comma 1, and it is parallel to x minus y is equal to 6. So if it's parallel, we know two lines that are parallel have the same slopes. So, So now I'm going to figure out what the slope is. So I'm going to go ahead and I'm going to add y on both sides. So I get x equals 6 plus y. I subtract 6 on both sides. So I get x minus 6 is equal to y, which is the same thing as me writing y equals to x minus 6. Here my slope is a value of 1. Two slopes that are parallel have two lines that are parallel have equal slopes. Therefore, this guy is great. We know this 1 over 1 is really a positive 1 all over 1. I can apply my same methodology. The numerator value goes in front of the x. The sign was positive. He's going to change to a negative. The denominator value goes in front of the y, and now we just plug in. So I have 1 times x, which is negative 1, minus 1 times y, which is positive 1. So we get x minus y is equal to 1 times negative 1 is negative 1. Negative 1 times 1 is another negative 1. So in this circumstance, we're going to get x minus y equals to negative 2. Solving for y, we're going to add y on both sides. So we get x equals to negative 2 plus y. Adding 2 on both sides, and we get y is equal to x plus 2. So that will be the answer to part B. And part C says an equation that crosses through the point 1, 3, and negative 2, 8. So we're going to cross through the point 1, 3, and negative 2, 8. So in order for us to write an equation of a line, we need both a slope and a point. So in this circumstance, we were given 2 points. So we're going to have to resort to using our slope calculation formula, which is y2 minus y1 all over x2 minus x1. Plugging this in, I will label this as my x1, my y1, my x2, and my y2. Plugging in, I'm going to have 8 minus y1, which is 3, all over x2, which is negative 2, minus x1, which is the value of 1. 8 minus 3 is 5, all over negative 2 minus 1 is negative 3. So my slope is equal to negative 5/3. And I'm crossing the point 1 comma 3. So I'm going to use my rapid way of writing an equation of a line. This value, the numerator, goes in front of the x. The sign changes from negative to positive, and the denominator value goes in front of the y. Now plugging directly in, I'm going to have 5 times x, but x is 1, plus 3 times y, but y is 3. So I will have 5x plus 3y is equal to 5 plus 9, which gives me a value of 14. But we have to solve this for a value of y, so we're going to subtract 5x on both sides. So this will give me 3y, 5x, is equal to negative 5x plus 14. Dividing both sides by 3, we get y is equal to negative 5/3 5/3 x plus 14/3. So again, this is just practicing how to write an equation of a line really fast. You're going to be doing a lot of this no matter which math course you're taking. It definitely is helpful to learn how to do this. And this comes to our last problem. And this tends to be a bonus question on my final. I think it's really good practice to solve this type of exponential equation. So the first step with doing so is that I recognize I have e to the x plus e to the negative x equals to 3. You can't just multiply by the ln on both sides. It doesn't work. What I want us to do first is I want us to translate that negative x to a positive exponent. So we're going to go ahead and bring this down to the numerator as a positive exponent. And that's still equal to 3. Remember, if I want to make this negative exponent positive, I can bring him down to the denominator. Now what I can do is I'm going to multiply the entire equation by e to the x. So that means I'm going to distribute it to this portion, I'm going to distribute to this portion, I'm going to distribute to this portion. So over here, I'm just going to show it. I'll do this part in red. So I'm going to have e to the x, and now I'm going to have times e to the x, because that's this portion right here. I'm going to have plus my e to the x gets distributed on top, so I have e to the x all over e to the x, and this equals to 3 times my value of e to the x. So I distributed this e to the x, should have done that in red, I'm sorry, to each one of these terms. So at this point, I hope we can see this is a value of 1. So we are going to have, I wonder if I can do this here, nope. We are going to have e to the x times e to the x plus 1 equals 3e to the x. So e to the x times e to the x plus 1 equals 3e to the x. And I know many of you can recognize that you can use your exponential properties and say that's e to the 2x. Since you're multiplying similar bases, you add the exponents. However, I'm going to show a little trick at this point. I'm going to say let y equal to e to the x. So everywhere you see e to the x, go ahead and plug in for y, which means that you are going to have y times y plus 1 equals to 3y. So everywhere I saw an e to the x, I plugged in a value of y. Y times y gives you y squared, plus 1 gives you 3y. And notice this is following the form of a quadratic. Set your quadratic set equal to 0. So we should subtract 3y on both sides. So I get y squared minus 3y plus 1 is equal to 0. So notice in this circumstance, I now have a quadratic in terms of y. Notice there's no factors of 1 that can give me negative 3. We're going to have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Here my a value is 1, my b value is negative 3, and my c value is 1 as well. Plugging this in, I'm going to have negative 3 plus or minus the square root, b, which is negative 3 squared, minus 4 times a times positive 1 all over 2 times 1. So this will give me 3 plus or minus the square root. Negative 3 squared is 9, minus 4 gives me a value of 5 all over 2. So here I have my value of y equal to 3 plus or minus square root of 5 over 2. However, we're not done. We know that I have two answers. I have y equals to 3 plus square root of 5 all over 2, and I have y equals to 3 minus square root of 5 all over 2. But I didn't start out with a value of y, I started out with a value of e to the x, and our goal was to solve for x. So now, everywhere I see a y, I'm going to plug in e to the x. So this is the same thing as me writing e to the x equals to 3 plus radical 5 all over 2. And this is the same thing as me writing e to the x equals 3 minus radical 5 all over 2. In order for me to solve for x, I hope we all recognize that we have to take the ln of both sides. So we're going to take the ln of both sides. Ln and e will cancel, and I get x equals to the ln of 3 plus radical 5 all over 2. And then over here, I'm going to see this cancels, and I get x equals to the ln of 3 minus radical 5 all over 2. The only thing I'd want you to check here is to make sure this is a positive value, and this actually is positive. 3 minus radical 5. Radical 5 is a value slightly less than 3, so we realize 3 minus the value slightly less than 3 will also be positive. Divided by 2 will also be positive. So your two solutions will be the ln of 3 plus radical 5 over 2 and the ln of 3 minus radical 5 over 2. If this problem gives you a little anxiety or a little stress, again, notice here is emphasizing bonus, bonus, bonus. It's definitely complex, but if you wanted to add a couple points to your score, I definitely recommend practicing through this quite a few times to make sure you understand all of the concepts, because it is a very formal problem that is involving so many different aspects of this entire class. I hope these videos were helpful to you, and I wish you all the best of luck.